Hello everyone, welcome back to my channel. If you are watching this video for the first time, please subscribe to my channel, like it, share it. Okay, now going to the topic. Now we are discussing about Atterberg's limit or consistency limits. These Atterberg limits are also known as consistency limits. These play a very important role in the geotechnical engineering aspects as these limits indicates the properties of the soil to determine the consistency, the resistance, the liquid limit, plastic limit and shrinkage limit, etc. So on what basis these Atterberg limits are classified? How the soil behaves depending upon the liquid limit, plastic limit, shrinkage limit. Let us discuss. The clay, silt, and fine sand are mainly depends upon the diameter of the soil particle. So, if the diameter of the soil particle is less than the 425 micrometers, then the clay, silt, and fine sand comes under this classification. And if the soil swells, the volume will automatically increase. This is mainly taken up from the formula V is directly proportional to 1 plus E. E here is nothing but the void ratio, and this is directly proportional to the indirectly proportional to the density of the soil, right? So up to the certain limit, if we increase the saturation level, then the volume of the soils remains the same, but beyond the full saturation of soil, now when the water content is increased, the volume of the soil increases, stiffness of soil decreases, right? Consistency also decreases, which results in the state of soil like this. State is known as plastic state. What is the consistency limit? Consistency limit is a boundary where the water content at which soil changes from one state to another state, right? These consistency limits are divided into three types based on this: liquid limit, plastic limit, and shrinkage limit. These are the three limits which decide the behavior of water in the soil. Now let us discuss about consistency. To know the consistency, we need to follow this consistency chart. Here we have x and y axis. On x axis we have water content, and on y axis we will
Y-axis
go for
indicates
the
volume.
volume. So there are three states where the soil behaves. One is liquid limit, second is plastic limit, and the third is shrinkage limit. Here we can find the different boundaries depending upon the water content, how the soil behaves here. If the boundary water content at which the soil changes from plastic to liquid state and vice versa, this particular limit is called liquid limit. And this can also be defined like the minimum water content at which soil starts to behave like liquid. This is the simpler definition of this liquid limit. The minimum water content at which the soil starts to behave like liquid, right? And next, coming to plastic limit, the boundary water content at which the soil changes from semi solid to plastic state. When the soil becomes semi solid to plastic state, the particular boundary water content, that is called plastic limit, or we can also define here the minimum water content at which soil starts to behave like plastic material. This particular limit is called plastic limit. Here, when the soil behaves like liquid, that is the liquid limit, and when the soil behaves like plastic material, that is the plastic limit. That is a simpler one, right? When coming to the shrinkage limit, in the shrinkage limit, the boundary water content at which the soil changes from solid to semi solid state, or vice versa. Soil changes from solid to semi solid state and semi solid to solid state. Both it is called shrinkage limit. Or the simpler definition here is the minimum water content at which soil becomes fully saturated. So at beyond this limit we cannot add more water rather than this, right? If we add also, no difference will be observed. The minimum water content up to which reduction in volume appears by drying is called the shrinkage limit. So when the soil is in liquid state, we when we dry the soil by placing it in the oven at some particular temperature, the soil becomes, after a few minutes or a few hours, the soil become plastic, will turn into plastic state, right? If this becomes more harder, if we remove more water content from this, then the plastic state will become turn into converted into solid state, semi solid state. And when this semi solid state again dried beyond the temperature, then this semi solid becomes to solid state. But at this particular point, after the conversion from liquid to solid state, again if we would like to take the water content from the soil, no water content will be left in the soil, right? So the reduction in volume is not observed, and the matter of state remains the same, that is the solid state will remains at the whole time. So this is all about the consistency limit, like liquid limit, plastic limit, shrinkage limit. Thank you for watching. Please share, like and subscribe my channel if you are watching it for the first time. Please support. Thank you.